Hello, I will talk about reliability in problem solving. First of all, let's start with the definition of reliability. It's the probability of a device or a system to work and keep working without critical failure. Let's talk more about reliability of a system. Let's say that we have device with reliability of zero point 0.9, then this device is considered to have high reliability relatively. But if a system consists of cascaded systems, each one of them has a reliability of X, then the total reliability is their product. Let's see this example. This is a cascaded system, all right? So we have five stages in this system. Each stage has a reliability. We can notice that each one of them has a high reliability relatively at its own. But when it's in the system, that's what we need to seek. We need to see what will be the reliability. The first thing we need to understand is that any failure in one of them will cause total system failure. Okay, because they are cascaded and because they are depend on each other. So any failure in any stage will cause the system to collapse, and this is what we will call a critical function. For the reliability or the total reliability of the system, it will equal their product. So it will equal R1 multiplied by R2 multiplied by R3 multiplied by R4, then multiplied by R5. And the result was 0.52. This system is not reliable or safe. So a critical function, it's a part of the system. When it fails, the whole system will collapse. This is why we have something called rule n minus 1. It's a rule used to increase reliability of the system by connecting parallel alternatives to each stage of the system. Let's talk about the types of parallel alternatives. We have repetitive of the stage itself, or we can use different system with the same output. So for example, we have this system, and as we see, each stage has an alternative, at least one alternative. Sometimes it has two alternatives. So, for example, in the first stage and the second stage, we have used a repetitive system. Okay, but in the third and the fourth, we have used different system in parallel in each stage. So let's calculate the reliability of each stage. So the reliability of each stage actually is because they are in parallel. First, we need to calculate the probability of failure of the system, and then we need to then from that we can calculate the reliability of the stage itself. You know, so the R total after applying or calculating the reliabilities of all the stages, which are the product of all of them, we have 0.9653, which is very high reliability and it's very safe system. So we can see adding parallel alternatives to each stage of the system makes the system reliable. On the other hand, we have this trade-off between reliability and cost. So increasing reliability will increase cost in general. In some complex cases, we will need to do cost optimization. So the final conclusion actually is about reliability in problem solving. When we are solving a problem, we should look into finding multi solutions and use multi systems or devices. This is the reliable action of a problem solver. Thank you very much, and I hope you have enjoyed. Please don't forget to visit our website.